Need it for the final. You need it for the final. Oh, that's good. Yeah. What happened? The color-coded chart. Yeah. Color coding works. That's why. Either way. Yes, it is. But the cumulative, sorry, the exam is made by West. It's not by the ACS. So yeah, it's not too bad. Yeah, he always proves the final a lot. That's good. Either way. So back to your extra credit exams. Since the average was really high, there weren't that many questions that you guys got wrong. There were only 3 questions out of 50 or less percent got them wrong. So I'm just gonna go over those 3 and then we can start reviewing something else. But let's start with this one. Okay. Take a second to read it, and I'm sorry that projector is not working. So if you just want to move to your left. So the CEOs would leave the high tide still turn. Okay, do we know what's the answer? Yeah, not everyone got the same questions, so it might be new for you. Oh, that's the turbulent, so it'll shift to the turbulent. What chapter is it from? Beautiful. It is 15. It's the benzene, yeah. Alkylation. Perfect. Once chlorine leaves, yeah, you form a carbocation. That was the main part of alkylation. But what's the answer? Jimena, go for it. No, I did not. I just created that this morning, so yeah, it's not in there. Not a high pressure. Right. Emily? 3? Okay, have one vote for 3. I got 5. We got 5. I got 5. What else? 5? 1? 1, 5. What else? Okay, we think it's 5, and if you chose 5, you're absolutely correct. But why though? What are you doing there? The math shift. Yeah, the math. Yeah, so this is the original alkyl halide that you start with. We know that chlorine goes away, and you're left with a primary carbocation. So we have a potential tertiary position to the left, so we're going to do a methyl shift. Which means we have this guy. Okay. Questions on the first one? We're good? We got it? Remember, you always want to make the carbocation really stable if possible. Okay. Let's look at the next one. If you got this question, don't just say the answer right away. Hold on a few seconds. I mean, it works, you just have to flip it. Yeah. Right, you're right. Two. Yeah, 2. Okay, do we have an answer? We don't have an answer? Okay, we're just munching, that's okay. What about on the back? I hear over here 2, 5.
2, 5, 1, 3. No, 4 is last. Wait, 4 is last.
4 is last, yeah. So, first of all, we know that the activator, the strongest one, is going to be your deer ether. Then the other activators that we have is the method group. Okay, now the rest of them are deactivators.
3 is 1, 3.
3, exactly. Remember, halogens are weak deactivators. And then just 1. And that's it. Okay. Questions on that one, guys?
I got the questions. I did it backwards. Like, I put 4 first. Like,
It was the same question, but he also asked for the increasing reactivity. So you might have gotten that. So yeah. Okay, let's look at the next one.
okay, what is called for the and you just plug it in. No.
Here, 5.
Okay. 5, 4. What else?
It's the numbers weird because I got this one wrong because 5 denotes this, 4 denotes that. So it's 4. I got this one wrong just because I
Oh shoot! Yeah, this is
That's
the one under it.
Okay.
So yeah, sometimes your professor is gonna do the answer choices a little weird and a little too stacked up. So please be careful to differentiate which one is A, which one's B. So it is gonna be 4. It is gonna be 4.
I looked at that. It's right above.
Okay. Questions on that one? Pretty simple. It was chapter 15. Everything was chapter 15. So it seems like you guys are pretty good with chapter 16. Abigail. So once this goes away, you're just adding that carbon chain, right? This is 1, 2, 3. This one's 1, 2, 3. That's the answer. 4? Yeah, that's 4.
No, you gotta roll the actual molecule.
Yeah,
Okay, sorry. There we go. Yeah, it's a little weird.
Yes.
So just be mindful of that when you take the exam. Okay. Okay. Questions so far on 15? Sorry? It's just a solvent. Yeah. It's basically just there to distract you. Okay. Let's do a quick raise of hands. How comfortable do you feel with chapter 15? If you feel really comfortable, raise your hand. 1, 2.
I like practice.
Okay, I was expecting more hands. Okay, lower your hands. What about chapter 16? Hello, that's not good. Okay. Yes. So remember, chapter 15 and 16, there was a lot to memorize. Actually, let's go back to the handout for this one. Actually, no. Let's go to the review. Okay. Now, if you look at the review handout, it's already posted. So you guys should be able to access it. If you can, let me know right away. But I decided to include something from chapter 12, oxidation. Why? Because you might see it in any multi-step synthesis, but from what I saw in the practice exam, he didn't include any of them. So this one is just in case, but Those are not protecting groups.
No, right, but it's like it reminds me of protecting group.
Yes, it's that chapter.
PCl3, PCl5.
There you go.
The other one was SOCl2.
Two. Yeah. Okay, so oxidation. Why would it be so relevant for this chapter, for 16? To make carbonyls, yes, specifically, remember, we're working with aldehydes and ketones. Okay, so those are the main ones that you should remember. But hopefully you do remember this. How many of you remember the oxidizing agents?
All I remember is
Okay, 2, 3.
yeah.
A lot of those. Okay, yeah, I'll have you with that. I'll take that. Okay, now, naming your ketones and aldehydes. We talked about those guys a lot.
Oh, yeah.
So yeah, that was pretty simple now. Oh, yes, but it's from chapter 17, so it shouldn't be on the exam. So it shouldn't be on the exam. Let me double check, yeah. I don't have that one memorized, but yeah, I know what you're talking about. Oh, yes, for sure. Yes, that's 16, but let me look up that. For aldehydes, if they're substituent, the prefix is oxo. For aldehydes and ketones, they're both oxo, yeah. Yeah.
What do you mean? Very sure.
If there's something, yes, I'm looking this. I'm looking this up. And this is from your professor, and actually,
It says substitute if a ketone is a substitute.
yes, if a ketone or an aldehyde, and you guys should be able to access this. I think so. Did you know? There we go. There we go. Okay. So yeah, this is from your professor, so we're just gonna follow that for this class.
Oh, sulfur, yeah.
Sulfur, we talked about those guys in 17. Where's the mercapto?
On the
On the thiol? That's just representing whenever your thiol group is a substituent instead of the main group in your pairing chain.
Halo, let's go.
Blah, blah, blah. Yeah. For the entire aldehyde group. Formal? I'm not sure if it refers to you're gonna switch the oxo-4 formula or it's gonna be oxo-formyl. The only one that really comes to mind is formaldehyde, which is somewhat similar, but that one's pretty easy. It's just 2 hydrogens on both sides. That's it. But again, the only ones that you should worry about are 3 and 4, aldehyde and ketone. You guys know 5 alcohols, and then yeah. Which one?
Only for the entire aldehyde group.
I'm not sure what he's referring to that in that case. I'm not sure if he is saying that you're gonna say formal instead of oxo, if you're gonna combine them both for oxo-formyl, but the only one that I know for sure is formaldehyde, which sounds very similar to formal. And again, formaldehyde is just a halogen, sorry. It's a carbonyl with 2 hydrogens on both sides, and that's it. Pretty simple. But yeah, he's not gonna go that in depth with the oxo portion. He's mainly trying to test you with AL and ONE. Anyway. Okay, let's pretend that we didn't see that portion. What do acids do? They protonate. They make the electrophile more electrophilic. What about bases?
Make more O.
Make more OH? I mean, yeah, in the terms of acid base, yeah. But they make the nucleophile more nucleophilic. Okay. Before I show you the spider web, how does a gem diol look like? What's the basic structure? Two OHs coming from the same carbon. What about a hemiacetal? Basic structure, how does it look like? Hemiacetal. One OH, one OR, and in the legs, remember, one of them needs a hydrogen. What about a hemiketal? What's the difference?
That's two R's.
The legs, exactly. Only the legs. What about the acetal form? Basic structure. OR, OR. R and H, yes, on the legs. What about keto? And legs. Beautiful. Okay, and now I can show you the spider web. Okay. So hopefully you guys remember the spider web. How many of you have memorized this or know the reactions really well?
Good question. What is that?
That's a gem dial.
That's an H, not an R.
That's still a gem dial. Yeah. Yes. Last. So yeah. Okay. What kind of reagent do I need to form an imine?
Imine?
Yes.
Need NH2.
That's it?
And
Tell me the degree and the name of the functional groups.
secondary.
Primary amine for imine. The enamine was the secondary amine. How does a hydrazine look like? What about phenylhydrazine?
NH2 and then NH with a phenyl.
With a phenyl. Beautiful. What about hydroxylamine? How does that one look like?
That's with the OH, so it's an NH2 attached to an OH.
Beautiful. Okay, so now we can look at the rest. Okay, there was one reaction that had specific rules, which was the enamine formation. What's the requirement for that reaction? Alpha hydrogens. You need alpha hydrogens. If you don't have those, it's just going to be no reaction. I'm sorry? The one that creates the most stable double bond. Remember, the goal is always to create something really, really stable. So as far as double bonds go, the more substituents we have, the better it is. Ooh. Okay, and alpha hydrogen are the ones connected to the carbons adjacent to the carbonyl group. So in this case, we only have those two alpha positions. Now, if you have an aldehyde, that hydrogen, it's directly connected to the carbonyl area. So we don't have a carbon in between, therefore that hydrogen wouldn't be an alpha hydrogen. Exactly. Yes. Okay, and then we're gonna disregard the chapter 17 portion. You don't have to know it apparently for this exam, so pretty simple. Okay, okay. Let's talk about chapter 15. What's the rate limiting step for chapter 15 reactions? What's the rate limiting step?
Special word.
I need a special word. What's the special word?
Wait, rate limiting of what? The Aussie.
No.
Iridium.
The rhenium ion. Yes, remember. It's always the formation of the rhenium ion. Why does benzene go through substitutions rather than addition reactions? Beautiful, exactly. It is electron dense, but also it's because of what Sam said. You want to retain that aromaticity. The molecule is really stable, so we don't want to mess that up. Right. Okay. Do we remember the reagents for the different reactions? Do we know how to spot them? Okay. I see some empty spaces. Do we remember?
For alkylation?
Yeah.
Okay.
Because remember, the reagent is just an alkyl halide, carbon chain with halogen. Halogen goes away, you're left with a carbocation.
Right.
Everything that you see in the brackets, that's the electrophilic species. So it's the thing that's getting attacked.
That's good.
Attacked.
Oh,
Okay. Let's do some random practice problems. I don't want to do the ones in the review. Yeah. Mhm. Okay. For chapter 15, I didn't include retrosynthesis problems in the review because I forgot. There's only one at the very, very end. So let's practice that right now.
sulfur is the activator shall add some metal, but do the methyl first. Methyl.
What kind of reaction is going to do that? Yeah.
Oh, okay. So this
So you gotta do alkylation and then the sulfonation.
Yeah, sulfonation is a deactivator. Yep.
The alkylation adds orthopara.
So yeah, but that's not the only reason. What's the other reason?
Right. And then because the deactivator is
Exactly. If we were to do the sulfonation first, alkylation just cannot happen at all.
Well, you said those were the steps, I'm sorry, and you just said because you can't have a deactivator in it.
Because alkylation will not work
Yes.
in the presence of a strong deactivator. Okay, so that's what
Remember, your Friedel-Crafts reactions, they never work with strong deactivators or amines. And then for your alkylation, that's the one that forms the carbocation, therefore you can do rearrangements, if possible. Let's do this little guy. Yeah, I'm just gonna start drawing molecules.
That's good though. That's
okay. So OH is
What's the product? We're doing normal synthesis now.
orthopara. So then para. So you'll put the salt.
Para is gonna be your yeah.
Here is gonna be the major. What am I gonna add in the product specifically?
SO3H.
SO3H. Don't forget that hydrogen. Yes. Okay.
Question.
Yeah.
Functionally, where does the SO3H come from? It comes from the H2SO4, correct?
Yeah. The extra hydrogen, yeah, it comes from the Lewis acid. What kind of solvent do we always need for the chapter 15 reactions? A Lewis acid. It's always a Lewis acid. Don't forget that. If you don't have that, the reaction cannot happen.
It's like a metal with the
Okay. What's the product? Why?
No presence.
What chapter is this? Okay. How do we identify that we have a chapter 15 problem? Benzene. You see benzene? Usually it's just chapter 15. How do we know we're dealing with a chapter 16 question? Aldehyde or ketone. Basic. That's it. As long as you notice those guys, you know from which chapter it is. That's not the reason. A little close.
Electronics.
No alpha hydrogens.
Oh.
What kind of reagent do you have in there? What's the functional group?
Oh, a sickly.
A secondary amine. So we know that we have to form the enamine, which is one of the very few reactions that have rules. This one doesn't count as an alpha hydrogen. Do we have any hydrogens over there? Nope. So it's just simple, no reaction. Okay.
You were to take off the methyl from that, right, into butyl.
Then it's going to happen to the right.
Can we do that?
Yeah, real quick. Why not?
We did. And I completely
Oops,
forgot.
that's not good. Okay, who wants to show me the product?
No, somebody back there sounded confident.
Give it a try, Sam. You're the one who requested the problem. Give it a try.
I'll pick them.
The oxygen at the end, it is going to leave, yeah.
This is the one.
If there's enough hydrogen here,
It depends on the reagent that you have. Because, for example, if we had water instead, we're going to keep that oxygen. It's always depending on what you're trying to form. In this case, we're trying to form an enamine. So an enamine doesn't contain any oxygen. And that's why I'm going to get rid of that oxygen. That's it. Great job.
So you did talk that.
The lumber and the nitrogen, yeah, it's going to do the nucleophilic attack. Want to draw it out? It can be a strong base as well.
That is
There-
the bond, yeah.
Yeah.
You go to this mechanism real quick.
God, sure.
Ah.
Okay, that's fair.
I requested just because I will feel better.
Okay, that's fair. Sure. Okay. Actually, that just reminded me. Okay, let's go back quickly to chapter 15. What's the electrophile and what's the nucleophile?
The electrophile is always the carbon.
Yeah, the carbon is only the electron. Yeah.
Chapter 15. We're going back to 15. What's the electrophile? What's the nucleophile?
Oh, the benzene. We're thinking of benzene.
What's benzene?
No, we're not looking at carbon. We're looking at benzene.
Benzene. Think about
is
benzene groups.
the
Benzene.
electrophile.
Benzene. 15.
Is the electrophile.
Benzene is the electrophile?
Yes, no.
Why is the nucleophile?
Oh, okay.
Why is it a nucleophile?
Yeah.
The double bonds are very negative. And it wants to grasp.
Yes. So benzene is very electron dense, so it's going to be the one doing the attack. So whatever's on the arrow, that's your electrophile. Now, going back to this guy. What's the nucleophile? What's the electrophile?
The electrophile is carbon.
Yes, whatever's on the arrow, that's going to be your nucleophile. So they're inverted, basically.
Has more double bonds.
I don't think that
No, because
No,
No,
this one isn't the
because this
nucleophile.
one has more double bonds, but that's the electrophile. The other one doesn't have any double bonds. So yeah, that's not a good rule to follow right now. But for 15, yeah, the more double bonds, yeah. Okay, so we know that our nucleophile is going to be doing the little attack over here. And then we have to kick up the electrons towards the oxygen. So we're going to be forming this little guy. I'm going to have O minus, and then I connect the nitrogen. Okay, what's going to happen now? Say it again, Emily.
Yeah, the negative O is going to take the H.
So yes,
Oh, yeah.
But you have to protonate it first because oxygen negative on its own, it's not going to be the best leaving group right now. So we're just going to transfer that hydrogen over here, which is going to give us this little guy. OH. Then we have a neutral. Now what's going to happen? They go down, and then what am I going to kick out? What proton that's left over?
Oh, that's not a carbon?
This one? This one? That's part of your aldehyde, and it's not really the most acidic proton, so it wouldn't take it. It's not the most acidic proton.
Where would it take the next proton? Or does it just stay as
It's just gonna stay as OH minus, or I didn't give you the solvent, so we can assume that whatever solvent was provided, that's the one that's gonna protonate it and make just water. So everything's stable.
So we're saying that OH itself is a better leaving group than
And just O?
No, on this step right here, where, yep. We're saying that the OH is a better leaving group than
the nitrogen?
Yeah.
Yes. And it's because
so this molecule would, if this molecule existed, it would automatically form an O.
Because oxygen is more electronegative. Remember, you're going to have good leaving groups whenever they're able to withhold a negative charge better. So yeah, oxygen is more electronegative than nitrogen.
So it'll put electron density towards it.
Okay. So now we start forming something similar to the product, but not quite yet. Is that it?
No, positive charge is not negative charge.
Positive. Okay. How do you fix that? Which alpha hydrogen? The only one on the right. Beautiful. So we're just going to be taking away this hydrogen with OH minus. Whoops, that's not correct. Whoops, sorry. Okay, then we shift the electrons to make the double bond, and then electrons go back up to nitrogen. So everything is neutral and happy at this point. Okay, we have this guy. So pretty much the last step is like an elimination reaction to what we saw in chapter 7, back in Orgo 1.
So OH takes the alpha hydrogen and then the double bonds.
Yes. You need some sort of base for this reaction to work. Questions so far? So far we're good? Higher or there? Okay. Okay.
Oh, I see what you're saying.
Okay. So let's rank those carbonyl groups.
Reactivity.
Yes,
So
based on reactivity.
Right.
Why the one on the right?
Less reactive.
Exactly.
Then alpha left. Then the second to the right. I will say middle one over the one on the left.
What do we think?
Which one do you think for the right? I feel like
Remember, what's the whole role of your carbonyls for chapter 16? Are they the nucleophile or the electrophile? Electrophile. So it's going to prefer to have less electron density.
Electron density, because you have either, the three methyls and then the other side with the whole benzene full of electrons.
Which one gives you more electron density? Benzene or terbutyl? Benzene. So that's not going to be the most reactive for that reason. So it's 4 or 5. I'm sorry, that's a 5.
Okay.
That's a crappy 5. Yeah. Okay. Questions on reactivity. Okay, remember again, it's just based on steric hindrance. The smaller you are, the easier it is to attack you. And let's do... Okay. What's the name of the reagent?
No, it's no, you're right. It's hydrazone.
In, because it goes in the reaction. Okay, so what's going to be the product? Hydrazone. How's it going to look like?
Top the head.
Is it going to matter which N? Which nitrogen?
Negative.
This case now. Okay. Can I form E and C isomers?
No, because they're stereochemical. It's symmetrical.
It's symmetrical. Exactly. What if we change it to this? Let's do that. Actually, no. Yeah, let's leave it just like that. Okay, who wants to solve that one? I want the major product. Okay, this time you're volunteering yourself.
Yeah.
Do you want to do it? Okay, we're just...
Cool.
Yep.
Oh, yeah.
You want everything neutral. Okay, is that the major product? Yes. So what form is this, E or C? E. Exactly.
More stable, yeah.
That's why it's more stable, therefore the major product. The C isomer is just going to be your minor product. It's still going to be formed, but it's just going to be minor.
And that also includes, like, when you make, you make this reaction happen, the E is going to be prevalent, but you'll still have C.
Yeah, right? You're going to create both. Yeah. But the percentage is going to be different. Yeah.
Not an organic.
Still a great job. We got the product, so that's all that matters. Exactly.
I can 12 circles on the exam. That's all that matters.
That's all that matters. Okay. Let's say that I were to add HCl. Let's talk about the mechanism. What's going to be the very first step? Yeah, so remember, your oxygen is going to gain that hydrogen, which gains a positive charge. So now it's more electrophilic. What would happen if I give you this instead? What's going to happen with the mechanism? Perfect, yeah. Okay.
What would it do to the product though?
So the
It would
product,
make it
they're
same
both gonna
product.
create the same exact thing.
Okay.
Mechanism wise, the catalyst works differently, but that's it. That's for whenever you have your reagent as an alcohol
Would
group.
it would make the reaction faster?
Yes,
Base catalyst and an acid catalyst?
yes. Okay. Ba-ba-dum.
Make the reaction slower.
No, and it wouldn't be called a catalyst.
A catalyst by definition speeds up
Yeah.
reactions.
Antagonist, maybe? It depends on what sense you're talking about. If it's
No,
related to
that's
enzymes, then yeah. If we're talking about enzymes, then it should be an antagonist. Or it can just be some sort of inhibitors. We have a bunch of them, so yeah. But you're gonna learn that more in biochem, so next semester. It's not bad. It's not bad. Oops. Okay. Major product again. Who wants to do it?
Acid, this was one of those where.
Okay, Sam is just working. Go for it.
I'll be honest, it's like a really.
Say it again. Why that one specifically? That's not the reason. That's not the reason.
No, because that's the two. That's the secondary part.
We're cleaving?
He said 312. You know what I'm saying?
Okay, so one, so you prefer it here.
No, I mean, yes, but no.
Okay. First of all, what chapter is it from? 15 or 16? 15. We see benzene? 15. Okay. 15, it's all about adding stuff. We're not cleaving anything. Not cleaving anything.
Oh, okay. You can only click on double bond. Oh, activators versus deactivators. That's right. So either.
Think about those guys.
Oh.
Which benzene is going to be the reactive one?
I'm thinking cleavage because I was on the practice exam, and that's like I said, I took it twice, and I think there was a question on this, so I'm thinking that too. Or no, really. No, wouldn't the bromine just attack the
Okay, take your time. You guys can look back at your notes. Talk with each other.
An activator will add support to error. This is an activator.
Which one is an activator?
This is the activator. This is the activator for this.
By the way.
It's the same thing.
No. Look for the direct connections.
Yeah. So then you put the pair of, pair is very much.
Okay, so you
And then
got.
for the reagent, it's gonna shift. You know what I'm saying? So from 5 rays to.
I have a great idea.
Okay, we're transferring over to Juan.
Don't want to delegate.
Right. So it's this kind of leaves when you're left with a positive here, right? So then we have this. But then this fits into here.
Beautiful. Hydrate shift.
Right, and then this gets out to the pair position. So then the product's going to. And then it's a pair, so.
And great job. That's your major product. Yes. Thank you.
Oh yeah, you probably have to pull up the chart. Yeah, the activated chart.
Okay. So practically whenever you see two benzene groups in the same molecule, you have to see which one is going to be the one reactive at that moment. Okay. So pretty much you can always just slice it in half just to see. You're not cutting the rings, just to see. Okay. Then you're going to look at what's directly connected to each of the benzene groups. On the left side, we're connected to a carbon group. Carbon groups, activators or deactivators? Activator. What about on the right side, the one that's connected to the oxygen? Activator as well. Now, what happened whenever we had two activators? Which one gives you the major product? So it's going to be the one on the right. It's by inductive effects, yeah, in a way. So that one goes ortho and para, and of course, para is going to be more stable, less steric hindrance, so everything's happy. Questions on that one? We're good? Yeah. And actually, we're going to stop right here, and then I'll see you guys at 3 p.m. in GS 118.
I'll be back.
118.
Clarify. It just came out 15, 16 pages, right?
Yes, just 15 and 16.
Okay, because you're right. The patent page is question from chapter 14.
Yeah, he did include some. I'm not sure why. I mean, I can see why. Because chapter 15 is related, but I was not expecting him to throw questions like that.
So, but those are chapter 14 questions on the exam, on like the actual exam.
On the actual exam, I doubt that there are going to be chapter 14 questions, but still, it can always be a possibility.
If you find that interesting, you would honestly be very well done. We have to memorize all that crap.